Section 14.4 deals with similar shapes and scale factors. No more drawing of shapes in terms of on grid and then enlarge them and that sort of thing. This is actually calculating based upon the knowledge that similar shapes have same corresponding angles and they have corresponding lengths in the same ratio. So let me just go towards some grade A thinking. This is not any particular question at all, but this knowledge is required to do all the grade A questions from page 206 onwards, where they're grade A rated and slightly beyond that, depending on the complexity of the storyline. Just consider this for a minute. Here I have, the pen works, a line, let's call it 1 centimetre long. Here I have a line 2 centimetres long. Again, it's obviously very rough. Now the ratio of the short line to the longer line is clearly 1 to 2. So if I write down here linear ratio, in other words the ratio of the length of one line to the other, ratio on, is going to be 1 to 2. Now the units are comparable, centimetres and centimetres, so I don't have to write centimetres there and centimetres there, right? So linear ratio is 1 to 2. If I have a square of side 1 centimetre, like that, and I double the bottom side and all the sides around are doubled, okay, so the length has increased 2 centimetres instead of 1 centimetre all round. Now if I look at the area of this little one here is 1 times 1, 1 centimetre square. Now if I look at the area here, 2 times 2 is 4 centimetres square. So if I look at the ratio of their areas, or area ratio, I have in fact 1 to 4 and not 1 to 2. So get rid of that unnecessary colon. Is that alright? So the area ratio is 1 to 4, and all I did was double the side of this square. So if I double the standard linear length, going from 1 to 2 centimetres, it's a 1 to 2 linear ratio. If I double the same lengths but work out the area this time, working in 2 dimensions, we have a ratio of the areas of 1 to 4. Now no prizes for guesses where we're going. So here's a little baby cube now, and it's a 1 by 1 by 1 centimetre cube, so therefore the volume is going to be 1 centimetre cube, isn't it? If I take its older brother, its bigger daddy, call it what you will, and I do a great big cube there, it's going to go 2 centimetres by 2 centimetres by, let's put the 2 centimetres up there, 2 times 2 times 2, 8 centimetres cubed. And all I did was double the lengths of the sides, and I ended up with a volume which is 8 times as big as the original one. So this is the volume ratio. And that's 1 to 8. Interesting? I think so. Look at it. Double the length, 1 to 2, linear ratio. Double the length, 1 to 4, ratio of areas. Double the length, 1 to 8, ratio of volumes. That's interesting. And these are the basic concepts you need to answer some of the grade A questions, where they give you ratios in terms of their areas, volumes and lengths as well. So you've got to be able to get your head around this little thing here. Now let me just add another page, because I don't want to use some of my prepared questions. Look at this. If I've got an area ratio of 1 to 4, say, going back to this just here, if I've got that situation, then do you see that if I square root each side, I end up with 1 to 2. So if I take the area ratio and square root it, I end up with a linear ratio. Therefore, area ratio equals the let's have a look, equals the linear ratio that's been squared. Is that okay? So 1 times 1 is 1, 2 times 2 is 4. If I square root it down, I'm going from area back down to linear. Alright? Now look at it again. If I look at the volume ratio, going back to this previous page, I've got a volume ratio of 1 to 8 just by doubling the sides. So I've got 1 to 8. If I cube root the 1 and I cube root the 8, just fit it in there, cube root of 1 is 1, the cube root of 8 is 2. So therefore, the volume ratio is in fact the linear ratio cubed. So if I cube the 1, 1 times 1 times 1, I get 1. If I cube the 2, 2 times 2 times 2, I get 8. So there's always a direct link between the linear ratio and the corresponding area ratio, and the linear ratio and the corresponding volume ratio. Okay, so let's just recap then. We have linear ratio, we have area ratio is the linear one that's been squared, and the volume ratio is the linear ratio that's been cubed. And if you want to go backwards, then we're going to say area ratio square rooted equals linear ratio. And obviously you need to square both parts of the area ratio, both numbers, and if I cube root the volume ratio, I get back down to the linear ratio. Alright, so again, if you get these rules into your head, we can use them for some grade A questions. So I'm going to pause this as an introductory video to grade A stuff. I'm going to do a couple of questions in the next video dealing with grade B, but this grade B works towards grade A because it talks through some of these ideas I've just covered here in this first introductory video, and leads on to this understanding. So that's that then. Linear ratio 1 to 2, area ratio 1 to 4, volume ratio 1 to 8, and that's the summary of how the rules all connect together. So I'll stop there and prep for 14.4 proper by doing question 3 and 4 as a separate little video.